Hey everyone, and welcome back to another video on this channel. And today we're going to be going through some difficult questions on topics that haven't yet come up for the pure exam. So I have made this difficult on purpose because a lot of people said that the questions were quite difficult on Wednesday. So hopefully this can kind of prepare you for anything that might come up on Thursday's paper. I believe it's on Thursday. So there are, I think there's around 10 questions of varying difficulty, and with the marks again, I'd say don't follow them exactly. They are there for a rough guide, but obviously Edexcel will have marks in their different ways. So I've provided them. So there are some 9-mark questions parts, but I don't necessarily know if they would be 9 marks. And if these questions are too difficult, or if there's any topics I have missed, please put a comment or give me an email so I can actually change that for the next video, because I do plan to do one more video for Thursday. And before we continue, thanks for everyone who has been sharing that first video of my walkthrough. I do try to help as many people as possible, so if you do find it useful, I'd appreciate if you could subscribe and also share it with others. That would really help me a lot. And before we get started, what I'm going to do here is I'm just going to stop on the question so you guys can attempt it, and then I'll show you how to work through the question afterwards. You can just pause it every time I hit go on to a new question, and then we can go through it together afterwards. So let's get started with question 1. So we've got some partial fraction work here, but it's important to note here that we are going to do some long division because they have got a remainder here, ax plus b. And another way you can spot this is because the highest power on the numerator is 3, and the highest power on the denominator is x squared. So if the highest power on the numerator is higher than the one on the denominator, you know that there's going to be a remainder. So what we can do is we can do x squared. So we're going to expand this. So we get x squared plus x minus 2. And we're going to now do long division on this using the numerator. So 2x cubed plus x squared minus 8x plus 3. Okay, so we first have to think, how many times does x squared go into 2x cubed? That's going to be 2x times. Next, we have to multiply all of this expression by 2x to get 2x cubed plus 2x squared minus 4x. So now we're going to subtract, we'll call this equation 1 by equation. So we're going to subtract those 1 and 2. So we do 2x squared minus 2x squared cubed to get a 0, then minus x squared minus 4x plus 3. Now next step, how many times do we have to multiply x squared to get minus x squared? You multiply by minus 1. So you get minus x squared minus x plus 2. Now if we subtract 1 last time, we're going to end up with minus 3x plus 1. So we can now rewrite f of x as 2x minus 1 plus 1 minus 3x over x minus 1, x plus 2. So now what I can do is I can completely leave ax and b, so a and b. So I'm going to work on just splitting these into 2 more fractions. So I can define 1 minus 3x, x minus 1, x plus 2 as being identical to e over x minus 1. Actually, no, I can use the same letters here. So c over x minus 1 plus d over x minus 2. So let's multiply by x minus 1, x plus 2, sorry. So we get 1 minus 3x, c, x plus 2, plus d, x minus 1. So let's start by setting x equal to 1. So that gives us minus 2 is identical to 3. Not sure I put that arrow here, 3c. So c is minus 2 over 3. Now let's set x equal to minus 2. So we get 7 is equal to minus 3d. So d is minus 7 over 3. So now we can write our answer as f of x is equal to 2x minus 1 minus 2 over 3 x minus 1 minus 7 over 3 x plus 2. And a good way to actually test your answers here is if you look at your original equation, your original function. So we've got this whole fraction here. I'm going to type in the number 2 into my calculator and store it in the answer function. So I'm going to write out this whole expression. So I'm going to put 2 answer cubed plus answer squared minus 8 answer plus 3 over answer minus 1 answer plus 2. So I use x equals 2. This gives me 7 over 4. Okay, and if I do the same for my own expression, let's see what I get. So 2 answer plus 1 plus, so minus, so it's not 2 answer plus, it's 2 answer minus 1. And then minus 2 over 3 answer minus 1 minus 7 over 3 answer plus 2. And that also gives me 7 over 4. So just to be safe, I'm going to try out one more value. So I'm going to try out x equals 3. That gives me 21 over 5. And if I sub it into my original expression, it also gives me, if I use an x equals 3, it also gives me 21 over 5. So this is just a quick tip to maybe help you become more confident in your answer in an exam. So just test it to see that you get the same value for both of the expressions. So let's move on to part B now. So it's asking us to find the integral between 2 and 4 of this function in exact form. It's exact value. So 2 to 4, 2x minus 1 minus 2 over 3, x minus 1 minus 7 over 3, x plus 2 with respect to x. That becomes 2 to 4, that becomes x squared minus x minus 2 over 3 ln x minus 1 minus 7 over 3 ln x plus 2. Okay? So now we can just go straight into substituting our values in. 16 minus 4 minus 2 over 3 ln of 3. So I don't actually have to use the modular sign anymore because it's positive. Minus 7 over 3 ln of 6 minus 4 minus 2 minus 2 over 3 ln of 1 minus 7 over 3 ln of 4. So we can start off by cancelling ln of 1 because the ln of 1 is equal to 0. So we get 12 minus 2 over 3 ln 3 minus 7 over 3 ln 6 minus 2 plus 7 over 3 ln of 4. So I can kind of spot already that we're going to have to put it in terms of ln of 2 and ln of 3. So it's best to put it in as simplified as possible. So let's do 12 minus 2, so we get 10 minus 2 over 3 ln of 3. Now, here's where we're going to split and get the ln 2 and 3. So I'm going to split ln of 6 into ln 2 plus ln 3. So we're allowed to do that because the base is the same. And obviously, you know, the addition, if the base is the same, it's essentially a multiplication of 2 and 3 here. Then plus 14 over 3 ln of 2, because ln of 4 is ln of 2 squared, which is the same as 2 ln of 2. So I've just multiplied that by 2 and make that a little bit more clear here. Now, 2 to 10 minus 2 over 3 ln 3 minus 7 over 3 ln 3 minus 7 over 3 ln 2 plus 14 over 3 ln 2. And we're almost there now. So that's going to become 10 minus 3 ln 3 minus 7 over 3 ln of 2. Sorry, plus 7 over 3 ln 2. So I'm just going to write it in order here. Okay, so I am going to check this in my calculator just to be safe. I'm going to integrate my fraction here. So another quick tip that you can use to check it is obviously, first of all, calculate the integral, not only of your original answer, so using this split fraction, but also of the original function, because then you can also cross-check just to double-check, yes, my fraction is correct. So 0 to 2 of 2 answer, so 2x minus 1 minus 2 over 3, x minus 1 minus 7 over 3, x plus 2. Oh, sorry, not 0 to 2. I accidentally put the pounds of 0 to 2. So 2 to 4. That gives me an answer of 8.3215. Now let's test out my own answer that I got from my own integration. that gives me the exact same answer. So I know there that I have got the right integral. So that is how you do parts A and parts B. And let's move on to the next question now. Let's move on to question 2. So proving the trigonometric identity. So I'm just going to sit here for a second. So if you want to pause and work through the question yourself, feel free to do that. And now let's get started with the question. So cos 3x minus cos of x over sine 3x plus sine of x. So to be honest, the first thing that I'm seeing here is that I want to split up cos 3x and sine 3x into the following. So actually I'll write it out. Minus cos x over sine 2x plus x plus sine x. So that's going to give us cos 2x cos x minus sine 2x sine x minus cos x all over sine 2x cos x plus cos 2x sine x plus sine of x. Okay, so it does look quite intimidating, but let's work through this step by step. So I'm thinking first of all of factorizing out in the numerator cos x. So we get cos of 2x minus 1 minus sine 2x sine of x. And on the bottom, we'll do the same, but we'll factor out the sine of x. Oh, there should be a cos x here. So sine of x, cos 2x plus 1 plus sine 2x cosine of x. Now, let's think cos 2x is cos squared x minus sine squared x. Okay, so we can rewrite this as, there's two ways we can rewrite this. So either 1 minus 2 sine squared x, or we can write it as, so it'll become 2 cos squared x minus 1. Okay, so have I written that right? 1 minus sine squared x. Yeah, 1 minus 2 sine squared x. Yes. So we're going to rewrite this. I'm going to just follow it down here. So we're going to write cos x. And what we're going to do here is we're going to use the top expression because I want to cancel out the ones. So I'm going to use the top one because then it becomes 1 minus 2 sine squared x. So I'll write it out. Do I have enough space? Okay, yeah, I should have enough space. 1 minus 2 sine squared x minus 1 minus sine 2x sine x. And in the bottom, I'm going to do the opposite because I want to get rid of the 1. I'm going to use 2 cos squared x minus 1. So I'm going to get sine x, 2 cos squared x minus 1 plus 1 plus sine 2x cos x. Now, let's expand this. So we're going to get minus 2 sine squared x cos x minus sine 2x sine x all over 2 cos squared x sine x plus 2 sine 2x, sorry, cos x. So I can kind of see that if we sub out this sine of x in the top, we'll get minus 2 sine x cos x minus sine 2x. Do the same on the bottom. We sub out our cos x instead. We'll get 2 cos x sine x plus sine of 2x. Now, if you notice, actually, we can rewrite minus 2 sine x cos x as minus sine 2x, and the bottom 2 cos x sine x is sine of 2x. So this will become sine x minus 2 sine 2x, and in the bottom cos x 2 sine 2x, because this turns into sine 2x and this turns into minus sine 2x. Okay, so now we can cancel those out to get minus sine x over cos x, which gives us minus tan of x, which is exactly what they wanted us to show. That was for 4 marks. that is a bit tough for 4 marks, but hopefully that explanation makes sense. And let's move on to part B now. Okay, so for part B, we've been asked to solve an equation. And we've got it equal to √3 minus sec theta, and we've got a bound here between 0 and 2 pi. So our first thing is here, let's rewrite this. And we can see it, let's double check it's the exact same form. So we can rewrite this as minus tan of theta is equal to √3 minus sec theta. Okay. So I'm just going to rewrite this as minus sine theta, cosine theta equals √3 minus 1 over cosine theta. Okay. So I'm going to multiply here by cos of theta. So this is going to give me minus sine theta equals cos theta √3 cos theta. Save it to look like this, minus 1. Okay. So what I'm seeing here is if we shift to the left, I'm going to make this 1 minus sine of theta equals √3 of cosine theta. So it's a bit tough to spot here, but what you're actually supposed to do here is you want to square both sides of this equation. Okay, so 1 minus sine theta squared equals √3 cosine theta whole squared. So you get 1 minus 2 sine theta plus sine squared theta equals 3 cosine squared theta. And now hopefully you can see why we've done this, because now we can rewrite cosine squared theta as 1 minus 2 sine theta, 1 minus 2 sine theta plus sine squared theta equals 3 minus 3 sine squared theta. So I've just skipped a step there showing the bracket, just swapping that, showing the substitution. Hopefully that makes sense though. So this rearranges now to get 4 sine squared theta minus 2 sine theta minus 2 is equal to 0. So divide by 2 again. Minus 1 is equal to 0. So this is factorizable, I believe. So we get, let's just write it out like this. Sine theta equals 0. So we do minus 1 here, and then plus 1. So that gives us 2 sine squared theta minus sine theta minus 1, which is correct. So therefore, sine theta is equal to minus a half, or sine theta is equal to 1. Okay. So sine theta is equal to minus a half. Let's think about the solutions here. We've got this between 0 and 2 pi. I'm going to write it down somewhere I can remember it. I'm going to keep this in a box. Let's look at the left side first. So sine theta is minus a half. If we think about it graphically, between 0 and 2 pi, that's going to happen at 2 places. Okay, so it can either happen at, let's just write here, for example. So let's use our inverse function on our calculator. Yep. So you should get theta is minus pi over 6. So you should actually know that. I'm not sure why I had to put that on my calculator. So you should get minus pi over 6. Now you should know that you can do pi minus a solution to get your repeated solution for sine. So if we do pi minus this, we get 7 over 6 pi. Okay, so we know that it's 7 over 6 pi. And we can also do 2 pi plus our original, so minus pi over 6 plus 2 pi, because sine repeats every 2 pi. So you do minus pi over 6 plus 2 pi, and that will give you 11 pi over 6. Okay. Now, let's look at the right-hand side. Sine theta equals 1. Well, we know that occurs when theta is pi over 2. Okay. If theta is pi over 2, well, if we look back at our original equation, that can't be possible for 2 reasons. So we know that sec theta is 1 over cosine theta. However, cos of pi over 2 is 0. So we're not actually allowed to have theta as pi over 2 because this makes this equation undefined. So therefore, you can say theta is not equal to pi over 2 as it doesn't work with the original equation. Okay, so we can disregard minus pi over 6 because that's not in our range. We know 7 over 6 pi and 11 pi over 6 are within the bounds. So I'm actually going to just quickly double check them to make sure that they work. So let's try minus tan of 7 over 6 pi. So that gives me minus root 3 over 3. Let's try root 3 minus 1 over cosine 7 over 6 pi. And I can kind of see here, hang on a second, this isn't giving me the same answer here. So what does that tell me? That tells me that 7 over 6 pi is also not a solution. And the reason for this is because when we square both sides, sometimes solutions can be made. So it's important to always double check your solutions to make sure that they actually work with the original equation. Because now if I try 11 over 6 pi, I get root 3 over 3. And then I also get root 3 over 3. So I'm going to write here original equation. So that we can come to the conclusion now that 11 over 6 pi is our only solution. So we're going to do it here. Theta equals 11 over 6 pi. Okay. So there might be other methods that people find easier, or they might find mistakes in my methods. So these are the methods that I've just always been taught, and I find these ones easiest to work with. If I have made any mistakes, or if there's anything I haven't explained correctly, please also put that in the comments, drop me an email so I can correct that for everyone else. But it's just important to note that with this one, I did square. So you have to acknowledge that there is a possibility of making an extra solution. And that's why we only conclude with theta being 11 over 6 pi. Okay, so hopefully that makes sense for question 2. And now we're ready to move on to question 3. So I'm just going to leave it there for 1 second for everyone to have a go at. And let's start with this. So it's important to know actually what is the derivative of 2x? Okay, lots of people actually forget this one. So the derivative of 2x is going to be, so just as a note, the derivative of 2x is ln 2 multiplied by 2x. Okay, so 2x ln 2. So let's work through this now. So we just said that the derivative of this is 2x ln of 2. Now, as it's implicit differentiation, the derivative will be the same. Okay, so it'll be 2y ln of 2, but we have to remember to multiply by dy by dx. Okay, now if we think about 2x plus y, we can say that is 2x multiplied by 2 of y. Okay, so we can use the product rule for this situation. What's the derivative of 2x? Well, we've just solved that. So it'll be 2x ln 2, but we'll also multiply by 2y. Okay, so 2x ln 2, 2y. And what's the derivative of 2y? Well, we also just calculated that. So it'll be 2y ln 2 dy by dx, but again, multiply by 2x. Okay, so I'm going to clean this up a bit because it is very messy on the right-hand side. 2 dy by dx, and then we can work on grouping the dy by dx's onto one side to finish this question off. Ln of 2 plus 2x plus y ln of 2 dy by dx. Okay, so I'm going to do 2 steps at once. I'm going to shift the dy by dx's onto the left-hand side while simultaneously cancelling the ln 2's. Okay, so 2y dy by dx minus 2x plus y dy by dx equals 2x plus y minus 2x. So I have gotten rid of the ln's. So let's factorize out dy by dx to get 2y minus 2x plus y equals 2x plus y minus 2x. So now let's divide by that expression on the left-hand side to get 2x plus y minus 2 to the x over 2y minus 2x plus y. And now what we're going to do is we're actually going to use our original equation here. Okay, so I'm going to use the fact that 2 to the power of x plus y is 2 to the x plus 2 to the y. So use 2x plus y equals 2x plus 2y. So I can now write this as 2x plus 2y minus 2x over 2y minus 2x minus 2y. Now we can see that this becomes 2 to the power of y over minus 2 to the power of x. So this is 2 to the y multiplied by minus 2 to the minus x. Okay, so I can now write this as, I believe it just wants it as minus 2 to the y minus x. Okay, so how many marks was that? Roughly 5 marks. So important to remember the derivative of 2 to the power of x. That's a lot of people forget that. And that's how you do part A. Let's move on to part B now. Okay, so if we want a stationary point, well, stationary point implies, stationary point, we need dy by dx equals 0. Okay, so minus 2 to the power of y minus x equal to 0. So we'll just divide by minus 1, 2 to the y minus x equals 0. So hopefully you all can at least notice that you can't raise something to a power to get 0. So nothing raised to the power will give, any power will give you 0. So for example, 3 to the 0 is just going to be 1. Okay, so let's think now, how can we, obviously apart from this, if it's 0, I believe that should give you just 0, but obviously we've got 2 here. So we have to say that 2 to the y minus x is positive for all x, because we know that it's not possible for it to be negative. If you raise something to a power, it can't, for example here, 2 to the right of anything won't be negative. Okay, so we will say that 2 to the y minus x is greater than 0 for all real x, y. Therefore, dy by dx is never 0. So there are no stationary points. Okay, so that's how part B works. So just explaining that the function for the derivative can never be equal to 0. So we'll never have a stationary point. So let's work on part C now. So finding the exact coordinates of the points where the tangent is parallel to the line y equals minus x. So if it's parallel to y equals minus x, we can say that it will have a gradient of minus 1. It will have, because y equals minus x has a gradient of minus 1. Okay, so we can say then, therefore, we want minus 2y minus x to be equal to minus 1. So we'll divide by minus 2. So we divide by minus 1 to get 2 to the y minus x equals 1. Now, how do we get 1 by raising something to a power? Well, anything raised to the power of 0 will give you 1. So what that tells us is, or another way you could do this is just by doing logs, but you know that y to the minus x will be equal to 0. So y is equal to x. So let's now substitute this into our original equation of 2 to the x plus 2 to the y is equal to 2 to the x plus y. I think that was the equation. Yeah. So now let's use y equals x. So we get 2 to the x plus 2 to the x equals 2 to the 2x. So then we can say, well, that's 2 of 2 to the x equals 2 to the 2x. So we do 2 to the 2x minus 2x equals 0. So you can kind of think of this as 2 to the x squared minus 2 of 2 to the x. So this is kind of like a quadratic, because what I can do here is I can factorize out a 2 to the power of x, and I can say 2 to the x minus 2 is equal to 0. Okay, so I've just factorized out. It's kind of like a quadratic. Another way that you can do it, if you find this confusing, is define a to be 2 to the power of x. So you get a squared minus 2a is equal to 0. So a minus 2 is equal to 0. And then you literally get the exact same thing as what I've written down. Okay, so hopefully that makes sense what I've done. So as we said before, so 2 to the power of x cannot be equal to 0. So we know that 2 to the power of x must be equal to 2. So x is equal to 1. And well, before we said that y is equal to x, we can say that, I think, what did it want? It wanted just the point, exact coordinates. So we can say, therefore, the point is 1, 1. Okay, so that is question 3 done. Hopefully that does make sense. So to show that and explain mathematically why there's no stationary points and finding the exact coordinates of the point. Okay, so now we can move on to question 4. Okay, so question 4, we've got some parametric integration and some finding coordinates. So again, here, this is what I talked about. So the fact that it's 9 marks, that's very extreme. I don't think they would give something like that, but this is just for practice, obviously. So have a go at this, and let's start with part A. So if it intersects the x-axis at the points A and B, okay, so obviously this question isn't how Edexcel would give it. They would obviously say something, but about which one's on the left, which one's on the right. But for this question, just you can define A and B as any of the two. So if it intersects the x-axis, we know that means that y will be 0. So y is equal to 0. So 4 cos squared t is equal to 0. I'm just going to box this just in case. So cos squared t is equal to 0. So we can also just say that we can root both sides to say that cos of t is equal to 0. Well, we know in this domain that we have, if we also draw out the graph, it will look like this. And we know that it's equal to 0 when t equals plus or minus pi over 2. So now what we're going to do is we're going to substitute that in to x. So we're going to say at t equals minus pi over 2, x is equal to 2 sine minus pi over 2, which is minus 2 of sine pi over 2, which is minus 2. At t equals pi over 2, x equals 2 sine pi over 2, which is 2. So we can define A to be minus 2, 0, and B to be 2, 0. So hopefully that makes sense for part A. Let's move on to part B now, so some parametric integration. So we know that normally when we integrate, this is just as a thing, so we know that it will be y and then dx, because you have y as a function of x. When we're doing parametric integration, we're going to write it as y dx by dt. So the way that I used to think about it is, well, this works because in my head, I would say, okay, well, these two can cancel out to give us dx. That's kind of how I would think about it. Okay, so let's start with this. So x is 2 sine t. So the derivative of this, quite simple, will be 2 cosine of t. So let's work out the bounds. So we know that it is bounded by the curve and the x-axis. Okay, so that will just be between minus pi over 2 and pi over 2. We're going to be doing our integration because it's bound. That's 4 cos squared t is going to be above the x-axis for those. So we do the integral between minus pi over 2 and pi over 2 of, so y is 4 cos squared t, and dx by dt is 2 cos of t, and multiply that by dt. Okay, so this is going to give us minus pi over 2, pi over 2. I'm going to sub the a out, so I'm going to factorize it out, sorry, cos cubed t dt. Okay, so this is where I might have overcomplicated it, but the way that I have done this is I've split up cos cubed t into cos of t and then 1 minus sine squared t. So I have skipped the steps showing that I've split it into cos t and then cos squared t. But all I've done here is I've just substituted 1 minus sine squared t for cos of t, for cosine squared of t, sorry. And the reason I've done this now, hopefully it will make sense once I go through it. Pi over 2, let me fix this, sorry. Pi over 2 cosine t minus sine squared t cosine t. The reason I've done this is because it allows me to use the reverse chain rule. I think that's the right word for it. I used to get confused between the two, but let me explain. If I take the derivative of sine t to the power of 3, okay, that will give me 3 sine squared t. So 3, let me write it like this, lad. Sine t whole squared cos t, which is 3 sine squared t cosine t. We can see that that is very similar to our expression here. Okay, actually, let me include the minus here. It's very similar. So how am I going to adjust? Let me multiply this by minus a third. So I'm going to multiply this by minus a third. And if I multiply this times by minus a third, if I multiply this by minus a third, that gives me minus sine squared t cos t. So hang on a second. I can rewrite my integral as minus pi over 2 cosine t minus a third sine t, so sine cube t, as such. Okay. Oh, sorry, hang on a second. No, that's not how you're supposed to write it. Apologies. You're supposed to write it like this, because that is what our integral is going to be. This is what our integral will be. Sorry, I used the wrong notation. So it'll be sine of t, and there'll be minus a third sine cubed t between minus pi over 2 and pi over 2. So now what we can do is just substitute our values in to get, sine of pi over 2 minus a third sine of pi over 2 cubed, and then minus sine of minus pi over 2 minus a third sine of minus pi over 2 cubed. I believe, yeah, that should be fine. And then close the whole bracket and close this big bracket there. Hopefully that's still readable. So sine of pi over 2 is going to give you 1. Sine of pi over 2 obviously is 1. So 1 cubed is 1, so minus a third. Now minus, so sine of minus pi over 2 is going to be minus sine of pi over 2. So this will become minus 1. And then again, if sine of minus pi over 2 is minus 1 cubed is again minus 1. So we do minus 1 times a minus a third to get plus 1 over 3. So that gives me 8. So 1 minus minus 1 is 2. Then minus a third is minus 2 over 3. So I can simplify this to 8 times 4 over 3, which is 32 over 3. So again, a way that we can check this is a bit longer, but I'd say it's worth it just in case, is we can write this in terms of, or you can even write it like that, or you can check it in your calculator. So before I do that, I was going to say you can write this in Cartesian form. It is a bit of a longer check, but it also makes sure that you've done your parametric integration correctly. So if you write y in terms of x, you would get y equals, so 4 sine squared t. I want to say 4 minus x squared. I think you get 4 minus x squared, and then you can check your integral by converting your bounds also to as it would be in a Cartesian equation. But I'm going to check it using my parametric. So we sub in minus pi over 2, and then 8 cos cubed t. So 8 cos x cubed, and it gives me 32 over 3. Okay, so that's how you would do your parametric integration for question 4. I hope that's made sense. And we can now move on to question 5. Okay, So we've got some logs and simultaneous equations here. And well, the first thing I'm going to do is I'm going to rearrange the bottom equation to get it all in terms of 3. Okay, so what I mean here is I can rewrite 3 to the x times 9 to the y equals 27 to the 4 as 3 to the x times 3 to the 2y, 3 to the 12. Okay, because 27 equals 3 cubed, so then I can do 3 cubed and then multiply that by the other power of 4 to get 3 to the 12. So then I can say, well, x plus 2y equals 12. So I'm going to keep this here, and now I'm going to work on the first equation. Okay, and just as a quick note, the reason you can get x plus 2y equals 12 is because we all have 3 here. So 3 to the x, 3 to the 2y, 3 to the 12. The only way they're going to be equal to each other is if x plus 2y is equal to 12, because this can be written as 3x plus 2y equals 3 to the 12. Okay, so now let's work on our equation involving logs. And what we're going to do here is we're going to use our change of base formula, because I really want to get this 4 into a 2. Okay, so I can use log 4y. Okay, so I'm going to say that this is equal to log 2 of y, okay, over log 2 of 4. So the change of base formula is essentially you pick your base, okay, so that would be the same on both the numerator and the denominator, and then in the top, inside the bracket, you'll have what was originally there, and in the bottom, you'll have what your original base was. Okay, so now log 2 of 4, well, 2 squared is 4, so I know that this is going to be a half log 2y. Let's rewrite this equation. 2x minus half log 2y is equal to 1. Now I'm going to rewrite this as log 2x minus log 2 root of y. Okay, because I've done power rule there. So I have shifted this power to the top of here, which is a rule of logarithms. Okay, so now I can say that this is log 2 x over root y is equal to 1. Now I'm going to raise both sides to the, so I'm going to do 2 to the power of log 2 x over root y and 2 to the power of 1. So that will give me root y equals 2 to the power of 1. Now, because it's log 2, so if we do 2 to the power of it, it's essentially acting as an inverse function. So that will become x over root y, and 2 to the power of 1 is obviously just going to be 2. So we'll get x equals 2 root y. And if we look at our original equation, x plus 2y is equal to 12. So let's sub in 1 into equation 2. So we get 2 root y plus 2y equals 12. Okay, so 2y plus 2, I'm going to divide by 2 actually. So y plus root y minus 6 is equal to 0. So I've just divided by 2 and rearranged. So this is going to be a quadratic, but in terms of like y to the power of a half. So it'll be y to the power of a half, y to the power of a half equals 0. Okay, or I'm just going to do it as root y because I think that would be more easy to understand. So I'm going to write this as plus 3 and minus 2 because this is factorizable. Another suggestion, what you can do, as I said before, if you set a to equal root y, you can write this equation as 2a squared, or sorry, a squared plus a minus 6 equals 0, and then factorize it exactly the same way. Okay, because obviously y is root y squared, so it's again a quadratic like that. So root y equal to 2 or root y equal to minus 3. So we're not going to look at negative roots in here. So we can say that root y cannot be equal to minus 3. So root y is equal to 2. So y is equal to 2 squared, which is 4. And if y is equal to 2 squared, well, we can say that x plus 2 of 4, so 2 times 4 is 12. So x equals 12 minus 8, x equals 4. So our solution will be x equals 4, y is equal to 4. So that's question 5. So The main thing there is spotting to do your change of base for your first equation. And then I'd say from there, it's a lot of manipulation and just some simultaneous equations there. So hopefully that explanation made sense for question 5. I believe we're roughly halfway through the paper. So let's move on to question 6 now. Okay, so let's continue with question 6. So part A, so we've got a circle here with center h6 and radius of 5. So I'm quickly just going to sketch it. I always like to sketch circles here. So 8, 6, radius of 5. So I do know that this isn't gonna go towards the origin, and we're pretty much calculating that in part A. But 8, 6. Okay, so it's asking us to find the exact distance from the origin to the center of the circle. So if we just draw like a line there, we can see here it's just going to be Pythagoras. So it will be 8 squared plus 6 squared square rooted, which is root of 64 plus 36, which is root 100, which is 10. So simple part A, just finding the distance from the origin to the center of the circle. So part B is now asking us to find the exact value of the sine of the angle between the two tangents. So I'm going to copy this diagram down because it's going to help me a little bit. I'm going to get rid of the labels here, and I'm going to draw my two tangents. So I've got one going this way, one going this way. So get rid of these labels, and I'm going to draw these two lines here because an important property to know is, I think it was GCSE you learn, that the radius intersects the tangent at a right angle. So this is a right angle, and this is a right angle. I'm going to label these two angles both as theta over 2 because this line to the origin bisects this perfectly down that angle perfectly down the middle. So I can label both of these as theta over 2. Now let me draw the triangle out on the side. So we have theta over 2. This length here is just going to be your radius. So this one here is just going to be the radius. So that is going to be 5. And we just calculated the hypotenuse here to be 10 in part A. So sine of theta over 2 is a half. Okay, so that means that theta over 2 is equal to 30 degrees. So theta is equal to 60 degrees. And what do we know about sine of 60? Well, sine of 60 degrees is root 3 over 2. So that would be your answer for part B. So just spotting that it perfectly cuts the angle in two, and then you could use your double angle formula here, but I think finding the actual value of theta is much easier. I think you can use both degrees or radians for this. And now for part C. So again, I don't really need to copy it down, but I'm just going to explain my process here. So if we think about it, we are trying to find the equation of the tangents in the form of y equals mx. Okay, so we know we've got two possible tangents here, right? And what I'm going to do is I'm going to expand my equation of the circle first. Okay, so I'm going to open up the brackets. So x minus 8 whole squared plus y minus 6 whole squared is equal to 25. So x squared minus 16x plus 64 plus y squared minus 12y plus 36 is equal to 25. I'm going to sub in y equals mx. So you get x squared minus 16x plus 64 plus m squared x squared minus 12mx plus 36 equals 25. Now I'm going to combine my like terms. So I will get 1 plus m squared x squared. Okay, so I've combined my x squareds. If we combine our x's, so minus 16 minus 12m, and then plus 75 is equal to 0. Oh, sorry, there should be an x here. Now what I'm going to do is, I'm going to do the discriminant. Okay, so if we just isolate it, we just think about one tangent. The whole point of the tangent is that it's going to intersect at a single point. So our discriminant will be equal to 0. And you might be thinking, well, we've got two tangents, there's going to be two intersection points. But when we use y equals mx, we're just looking at a single line. We're not looking at two individual lines. by doing the discriminant is equal to 0, we're saying, okay, y equals mx will hit the circle only once. Okay, and you'll later see that we'll get two values for m, which represents the two possible tangents. If you write that the discriminant is greater than 0, you're essentially looking at a line like this, because it intersects the circle twice. So it's important that you set your discriminant equal to 0. So minus 16 minus 12m whole squared minus 4 1 plus m squared 75 is equal to 0. So the numbers look pretty bad here, but I don't think it'll be too bad. So 16 squared is 256. So we have to do 2 times 16 times 12, which is 32 times 12, which I believe is 384. I'm going to check that just in case. Yep, it's 384. Then plus 144 m squared minus 475 plus 75 m squared, 0. So 256 plus 384 m plus 144 m squared minus 300 minus 300 m squared is equal to 0. So let's just simplify this a bit. So we should get, I'm going to shift everything to the right hand side. So we should get 156 m squared minus 384 m minus plus 44 is equal to 0. And I'm just going to put this straight away into my calculator. I don't think it says anything. Yeah, so I'm just going to put this straight away into my calculator. I feel like the numbers are going to be horrible here. 44. Yeah, so these numbers are quite bad. But I think that's also a part of these exams. So I remember, I know a lot of people, when they get numbers like this, they always second guess themselves. They go back, they correct something that actually didn't need to be corrected. So I think this also teaches you to kind of be confident in your own answers. So I'm going to show you the possible values here. So m is either is plus or minus 25 root 3 over 39. So your possible answers would be 48 plus 25 root 3 over 39x, and y equals 48 minus 25 root 3 over 39x. So as you can see, these numbers are quite bad. So they can look like you've done something wrong in your own like working out and everything. But it's very important that you trust your own process, your own working, because I've seen people, they get the right answer, they just completely go back and second guess themselves. So be confident in your answers. These are the right ones. So if you did this yourself and then came back to check where you went wrong and you got these answers, you're completely fine. So I hope this working made out for so all of this working out made sense for question 6. So let's move on to question 7 now. So we have got some vectors questions here. I remember this definitely didn't come up, and lots of people want some practice on this. So let's start off by finding vectors a, b, and ac. Okay, so I'm just going to label this O to A, O to B, and O to C. All right. So if we want to find AB, well, we can think about it as going from A to O, and then going from O to B. So A to O is just going to be the negative of O to A. So minus 3, minus 2, 1. And then O to B will just simply be 5, minus 1, 2. So that gives us 2, minus 3, 3 for AB. Okay, we can do the exact same thing now for A to C, because that is A to O plus O to C. So that will give us, so minus 3, minus 2, 1, plus 6, 4, 2, which gives you 3, 2, 3. Okay, so you can write it in this form, or you can write it in so IJK form. (2j plus 3k). So 2 minus 3, 3, and 3, 2, 3 for your answers. Okay, let's move on to part B now. So I think it's a show that the triangle is an isosceles. So the way we can do this is by calculating and showing that 2 of the sides are the same length, because isosceles obviously have 2 sides that are the same. So if we're trying to show that ABC is isosceles, so you have a quick sketch. Just, this is not accurate at all, but if we say we'll say something like this. Okay, this is A, B, and this is C. So what we can say is we can try and find, let's try with AC and B, AB, because they told us to calculate that. Sometimes they can hint as to what you need to use. So I'm going to try and use AB and AC. So I'm going to try and find the magnitude of AB first of all. So the magnitude of 2 minus 3, 3 is the square root of 2 squared plus minus 3 whole squared plus 3 squared, which is root of 4 plus 9 plus 9, which is root 22. Now let's do the same for AC. AC is, again, so we can see here straight away that the numbers, the magnitude of the numbers is actually the same here. Because we're getting, again, 3 squared plus 2 squared plus 3 squared, which gives us root 22. So then we have to give a conclusion saying that as AB is equal to AC is equal to root 22, the triangle is isosceles. So that would be sufficient for your conclusion. That would be how you would, hang on a second. So that is how you would finish part B, if you show that. And now, let's work on part C. They want us to find the exact area of the triangle ABC, giving us the answer in the form of half root K. So let's draw our triangle out something like this. Draw the triangle ABC, root 22, root 22, and we can label this angle theta here. Okay, and the method I'm going to do is I'm going to find BC, so then I can find out what our angle is, and then we can use half AB sine C to calculate the area. Okay, so let's now find out BC. So BC is B to O plus O to C, and B to O is minus 5, 1, minus 2. And then O to C is 6, 4, 2. So that gives us 1, 5, 0. So let's calculate the magnitude of B to C, which is 1 squared plus 5 squared, which is root 26. So we now know that this is root 26. So we can use now the formula, which is, so we say C squared, which is going to be root 26 squared. So root 26 squared equals root 22 squared plus root 22 squared. A squared plus B minus 2 root 22 cos theta. Okay, so this is 26 equals 22 plus 22. So root 22 times root 22 is going to be 22. So minus 44 cos theta. Then we're going to get, this is going to become 26 minus 44 equals minus 44 cos theta. So minus 18 equals minus 44 cos theta. So cos theta is 9 over 22. Now, we can't really find out theta because we have to find the exact form here. So it's better if we use the method of drawing out the triangle as such. So theta, 9, 22. Label this as x. So 9 squared plus x squared is 22 squared. So x squared is 484 minus 81. So therefore x is root 403. Now the area of the triangle, we can use the formula half AB sine C. B times sine of C, or sine of theta. So half times, actually I'm going to write here the modulus because they've actually defined A and B if we look up at the question again. So it's safer that we use just ABAC as such. So half times root 22 times by root 22 times by sine theta is going to be root 403 over 22 by using that triangle up here. And we know root 22 times root 22 is 22. So we can actually simplify that to root 403 times by a half. Let me just write that a bit nicer. There. So that means that k is 403. So hopefully that made sense, especially the method for part C. And now we can move on to question 8, which is a proof question. So have a go at this one. So you can pause it here and have a go. And let's start now. So prove by exhaustion that for all positive integers n less than 5, the value of n squared plus n plus 11 is a prime number. Okay, so exhaustion, all you have to do is just try n1, 2, 3, 4, because the integers that's less than 5. So if n equals 1, we get 1 plus 1 plus 11, which is 13. 13 is a prime number. N equals 2. 4 plus 2 plus 11 is 17. This is a prime number. N equals 3. 9 plus 3 plus 11 equals 23. This is prime. Whoops, this is prime. N equals 4. 16 plus 4 plus 11 is 31, which is prime. So now we can say, as all positive integers, as all positive integers, as all positive integers n less than 5 give prime numbers, the statement is proved. Sorry, I got a bit mixed up there. So there we've proved by exhaustion that for all positive integers for n less than 5, this value is a prime number. So now let's work on part B, proving by contradiction that log 2 of 3 is an irrational number. So our first step with the contradiction proof is assume that log 2, 3 is rational. Okay, so log 2 of 3 equals p over q, okay, where p and q are integers. So where p and q are integers and have no lowest common multiple. Okay, so not lowest common, they don't have any, and have no common factors. I'm not sure I put lowest common multiple. Have no common factors. So it's in when I say that, I mean it's in its fully simplified form. Okay, and obviously q can't be equal to 0 here. Okay, so now what we can say is log 2 of 3 is equal to p over q. So if we now raise both, so we do 2 to the power of log 2 of 3 and 2 to the power of p over q, okay, we can get that 2 to the power of log 2 of 3, as we said before, that's going to be essentially doing the inverse of itself. So we will get that 3 equals 2 to the power of p over q. So now let's raise both sides to the power of q. So we're going to get 2 to the p is equal to 3 to the q. This only works if p equals q equals 0. But remember, we had to define that q is not equal to 0. Okay, so that means that this is a contradiction, because any value p here, if you take any, as we picked integers, it's only going to be even. And for any integer q, that 3 to the q is going to be odd. So for p greater than or equal to 1, okay, so actually let me change my definition here. So I'm going to change it to p is greater than 0 and q is greater than 0. Like that. Okay, so I'm going to say for p greater than or equal to 1, 2 to the p is always even. And for q greater than or equal to 1, 3 to the q is always odd. This is a contradiction, as an odd number can never equal an even number. An even number. So therefore, log 2, 3 is irrational. Okay, so that is how you finish that proof for question 8. Hopefully that made sense. And now we can move on to question 9. So almost hitting the end of the paper. So using integration by parts twice to find the exact value of this integral. So I'm going to rewrite it here, 1e ln of x whole squared over x squared with respect to x. Okay, so I'm going to define u as ln of x whole squared and dv by dx as x to the minus 2. So that means that du by dx is going to become 2 ln x over x, okay, because we have to take the 2 to the outside, so it becomes 2 ln x, but we also have to multiply by the derivative of ln x. So the derivative of ln x is 1 over x, so it becomes 2 ln x over x. If we integrate x to the minus 2, it will become minus x to the minus 1. So let's do our first part, first integration by parts. So it will become uv, which is ln x squared, times minus x to the minus 1 between 1 and e, minus 1 to e, 2 ln x over x squared. We've got a minus here. Okay, so I'm actually going to shift that to the outside to get a plus. So 2 ln x over x squared with respect to x. So integrate by parts again. Parts again. And we will now use, again, u equals ln of x. Okay, and then we'll take dv by dx to be 2x to the minus 2. So you can easily take the 2 out. That's not a problem. I've just kept it in. Take the derivative of this. Du by dx is 1 over x. V is going to become minus 2 over x. Okay, I think that's, yeah, minus 2 over. But just one quick thing, I made a mistake here. I should be using different variables. So I will quickly just change that to be, I'm going to use p here, dp, and I'm going to use dq, I'm going to use q. It's not too big of a deal, but I just like to define new variables for this. So now let us write this out again. 1e. Okay, now we're going to plus, let's put a bracket here. So pq, so that'll be minus 2, so plus minus 2 over x ln x between 1 and e, and then minus the integral of minus 2 over x squared dx between 1 and e. And now you can see that this is much easier to integrate. So we can now write that the integral is equal to, I think it's best actually now that we start to simplify this expression. So ln of e, well, so ln of e is just going to be 1. So that's going to be 1 squared times by minus 1 over e, and then subtract, ln of 1 is 0, so that expression will just be 0. Now let's work on the next part. So minus 2 over e ln of e, as we said, ln of e is going to be 1, so it will just be minus 2 over e, so plus minus 2 over e, and again ln of 1 is 0, so we can just ignore that part. Now let's minus the integral of 2 over x squared. Okay, so that is going to become, if we think about it as, if we just write it down here, minus 2x to the minus 2. Okay, so we're going to add 1 to the power and divide by it. So minus 2x to the minus 1 over minus 1 between 1 and e. Okay, so this is going to become minus 1 over e, minus 2 over e. Now minus, so this is going to become 2 over e minus 2. So let's now minus 1 over e, let's simplify this. So minus 3 over e, minus 2 over e, plus 2. So 2 minus 5 over e. I hope I explained that well enough. So picking those two, so going through those two parts of integration by parts. And again, as a check, I will be doing this in my calculator just to make sure that I've got the right answer here. So between 1 and e of ln of x squared over x squared, and that gives me roughly 0.1606. 2 minus 5 over e, 0.1606. So there is a good check to make sure that I've done my integral correctly. And now we can move on to part B of the question, which is using a substitution to find the exact value of a different integral. So let me write this out now. So between 0 and pi over 2 of sine of 2x over 1 plus cos squared x with respect to x. So using u equals 1 plus cos squared x. Okay, so 1 plus cos squared x, we can take the derivative of this to be minus 2 cos x sine x, because cos 2x it's the same thing. You have to take the power outside the bracket, so you get 2 cos x, multiply the derivative, which is minus sine of x. So you get minus 2 cos x sine x, which is the same as minus sine of 2x. So if we want to solve for dx, we will just multiply by dx and divide by minus sine 2x. So dx equals minus 1 over sine 2x du. Before we do any more, before we put this back into the integral, we have to remember to adjust our bounds. So if u is equal to pi over 2, okay, sorry, if we have our bound as pi over 2, okay, we know that 0, and so u equals 1 plus cos of pi over 2 whole squared. Cos of pi over 2 is 0, so u is going to be 1. Our upper bound will be 1. If we try now using x equals 0, u equals 1 plus cos of 0 whole squared. Well, cos of 0 is 1, so it'll be u equals 2. So our integral is now going to be, our bottom one is going to be 2, our top one is going to be 1, sine of 2x over u times by minus 1 over sine 2x du. So you can see here these perfectly cancel now to give me 2, 1, minus 1 over u du. However, we can see here our bounds. You might be thinking our bounds are the wrong way around. So why don't we flip the bounds now? So we can put the 2 on the top and the 1 on the bottom. Okay. If we're going to do that though, it means you also must multiply, you must change the sign, you must flip the sign. So we're going to swap the bounds, but also swap the sign. So we get 1 over u du. Now the integral of 1 over u is ln of u between 1 and 2, which is ln of 2 minus ln of 1, which is ln of 2. So now again, we can check our answer by using this original integral. So 0 to pi over 2 of sine of 2x, 1 plus cos x whole squared, 1 plus cos x squared dx. And I'm going to make sure my calculator's in radians. So I get roughly 0.693. Now ln of 2 is also roughly 0.693. So that shows that my integral is correct. Okay, so question 9 done. Now we can move on to the last question of our paper, which is a binomial expansion. So you can pause it here if you want to have a go, and let's get started going through this question. So we've got binomial expansion of a plus bx to the power of minus 2, and we've been given the first 3 terms of the expansion, and we know that the constants are positive. Okay, so my first step here is let me take out the a from the brackets, because we have to have it in the form of 1 plus something x to the power of whatever. So become 1 plus b over a x to the power of minus 2. So 1 over a squared, 1 plus b over a x to the minus 2. So let's start expanding this now. I can already see what my a value will be, but I am going to expand it anyways. So 1 over a squared, my first term will just be 1. Then it will be nx, so it will be minus 2 b over ax. Okay, and now we just have to find one more term. It's going to be minus 2 minus 2 minus 1 over 2 factorial b over a x whole squared. And it will go on, but we're only concerned with the first three terms for now. So we can see here, our constant is 1 over 4. And our constant will come by doing 1 over a squared multiplied by 1. So therefore, 1 over a squared must be a quarter. So a squared must also be a quarter. So a is plus or minus 2. Sorry about that. So as a is positive, a is equal to 2. So after finding a, our next step can be trying to find b. So let's not forget we have this 1 over a squared. So our x term is going to be minus 2b over a cubed. So we can then say minus 2b over a cubed is equal to minus 3 over 8. So then 2b, as a is 2, 2 cubed is 8. So 2b over 8 is 3 over 8. So therefore 2b equals 3. So b is equal to 3 over 2. Now, last of all, let's try and find out c. So again, let's not forget our 1 over a squared. So we'll get that minus 2 minus 3 over 2 factorial multiplied by b squared over a squared, and then again multiplied by 1 over a squared is equal to, so I'm just going to write here as x squared term. So now let's simplify that left-hand side. So we get 6 over 2 factorial, which is 3. So 3b squared over a to the 4 is equal to c. Now let's sub in the terms we calculated. So that'll be 3 times 9 over 4. A to the 4 is going to be 16. So we're going to get, that's equal to c. So we're going to get 27 over 4 over 16, which is 27 over 64. Okay, so those are your three values of a, b, and c. So now let's move on to part b, which is asking us to find a set of values for which the expansion is valid. So you know our expansions are valid for x, for the magnitude of x less than 1. Let's not forget here, though, we have b over ax. So we want the magnitude of b over ax to be less than 1. So we know that b is 3 over 2 and a is 2. So the magnitude of 3 over 4x is less than 1. So we can multiply now, and we can say we can multiply by 4 over 3 and say, well, therefore, x, the magnitude of x has to be less than 4 over 3. So that is how you would get the values of x for which the expansion is valid. Okay, so now we can go to part C, and it says, using your values for a and b, find the expansion of the following up to and including the term x cubed. So let's write this out now in terms of how it will help us. So 4x, and then it is a plus bx whole squared. Okay, so that will be 2 plus 2 over 3 x to the power of minus 2. And the thing is, we already know the first three terms of the expansion. So we can actually write this straight away as 4x, then 1 over 4, and then minus 3 over 8x. And then we calculated c to be 27 over 64. So plus 27 over 64x squared. So we can use the information that they give us, because all we're doing is multiplying our original expansion by 4x. Okay, so we don't have to completely calculate it like a new one. We can just multiply our original by 4x. So this will give us x minus 3 over 2x. Oh, so this will be minus 3 over 2x squared plus 27 over 16x cubed, and then plus dot dot dot. So I think that's all it asks for. That's it. And I believe, so that is the last question that I put here in this paper. And I really hope that this was useful. Sorry if I made any mistakes through the paper or if there are a couple of cuts, but this was my first video before PO2. So going over topics that haven't been covered. If there's anything that I've missed, anything that I've made a mistake on during this paper, or anything you want me to go over, maybe some harder questions, some easier questions, specific topics, please leave a comment or email me. I've provided an email in the description, I think, and in my channel description. So please feel free to send me one of those. And if you find this useful, I really ask that you subscribe this and share with other people so as many people can benefit from this as possible. I'm going to try and do as much as I can to help you guys for your next paper and then also before the applied paper. So I really hope you enjoyed this one and good luck with your revision, and I'll see you in the next paper.